Hey everyone, in this video I want to walk you through the complete setup, and I know there have been many setup videos, but I feel like almost all of them are missing something. I want to show you the setup end to end and clear up a lot of the misunderstandings out there. So I'm going to connect to my board. Ignore the fact that I have multiple Bluetooth connections available. I'll just connect to the first one right here. The first thing you want to do is when you connect to the phone, you want to wait until here I have the package loaded. So I'm waiting for App UI to show up as a tab. Okay, now I have Start, App UI, and RT data. So everything is ready and loaded, and I will now go to the firmware section here and verify that I'm connected to my controller. If you're using something like a Thor or an X12, if you're connected and you see VESC Express or something else down there, that means you're not actually connected to the controller, but you're connected to the VESC Express module. So you gotta, in that case, press CAN. It's scanning the CAN bus, and then you should see your controller in the list of CAN devices. In my case, I'm already connected to the controller, so I'm good to go. And now I'm not going to do the setup from the beginning where you maybe need to load firmware and so on and you don't have a float package, but I'm going to do it so that if you already have a float package loaded, I have the refloat package, which in my opinion is the only package to be used going forward. The refloat package is loaded and I need to go into specs and we want to disable it. This is very important. You have to disable the package or else none of your motor setup will work correctly. So you want to disable the package, and any of these changes that I'm making here, disable, enable, changing values, don't actually happen on the board until you hit right. So I'm hitting this right button. Now it has happened. You hear the beep. I always attach a buzzer to the servo port just because I can't imagine working without one. But if you don't have one, it'll be silent and you just have to look at the display on your screen. So the first thing we're going to do is make sure your motor is nicely suspended, and we're going to run the motor wizard. So set up motors. It will ask you if you want to load the default parameters. Since I don't intend to preserve anything and I have a backup, by the way, I'll just say yes and just load all the defaults. And this is what you would start with anyway if you have a fresh firmware download. By the way, if you load firmware, any settings you've done before will be lost after loading firmware, right? So firmware wipes any settings that you may have. So in the wizard, we want to select EUC, hit next, and now we select large outrunner. Then override. You want to change the sensorless ERPM to 2000. Unfortunately, the plus minus buttons only add and subtract 1. So I'm going to type it in. And here, motor poles. We don't have a single one-wheel motor that is not 30 poles. So whether you have Hypercore, Cannon Core, Superflux, FOB 188, whatever it is going to be 30. So that's what you want here. And am I sure? Yes, I am sure. Also here, the battery type you never need to change unless you have some weirdo battery, but then the cells in series. So the Fungineer battery would be 20, a torque pack or a meat pack would be 18, and then you also need to know your capacity. By the way, these settings, the battery cells and the battery capacity, they don't affect how your board ride. It just is used for calculating your range and the battery percentage and so on. So it's not too critical. If you don't know it right now, it doesn't matter. It doesn't affect the motor detection or the whole setup. That will be it. We hit next. Yes, I'm sure. And this one also, a lot of people seem to skip it. I don't know how that happens, but you need to select direct drive. And then the wheel diameter, 280 is fine. And if you have a Burris 7, then maybe 300 is closer to appropriate, or 295. And now we're going to say run detection. So detect all motors over CAN bus. We want to uncheck that because we just have one motor, not multiple, like on an E-skate or something. So we hit OK, and now it goes. You'll hear this first sound. Then you see your wheel rotating like this. This is the flux determination. And then at last, it will rotate the wheel really slowly, detecting your Hall sensors. So that takes a few seconds, and then it will almost always report success. But that doesn't mean that it was actually working as it should. So I'm going to show the typical results that you should be getting for all the different motors. The results primarily depend on the motor. They don't really depend on the controller too much. So depending on the motor you have, you should get more or less the same results between all the different controllers. These here, I have R of 91, that looks decent. My L is 234, looks good too. Flux linkage 28. The wizard isn't always perfect. The most important thing you want to look for actually is at the bottom. Sensors, it has to say Hall sensors. If it says sensorless, stop right here. There is no need to do any other steps because your motor did not detect the Hall sensor cable. Very often, it will also say temperature compensation false in that case, but it means you either haven't hooked up your wires right, you haven't plugged it in correctly, or some people don't plug the cable all the way in, like the float wheel. So you definitely want it to say Hall sensors, or else you won't be able to continue. So we hit OK. All right, this forward and backward, it really doesn't matter. If you hit forward and it goes forward, that means you have a 50-50 chance that it'll actually balance correctly. So it doesn't even matter. I wouldn't touch it. I've never used it. I mean, you can press the button just to see that the motor turns. Okay, it turns. You can't trust it. It doesn't really mean much. And hit finish. Now we have that done. So after the wizard has been run, it sets several values incorrectly. So we want to override them and fix them. So we go into motor configuration. And the first thing we see, motor type is FOC, all that looks good. And we will go to currents. So these currents are very low, much lower than what we really want. So I have a little Fokker here with an MTE hub with N42 magnets, and it's a little cumbersome deleting all this here. I usually do all my setups on the PC, but most people seem to use the phone, so I'm doing that here. I'm trying to put in 120, so I'm struggling. Damn it, still don't have it. Maybe all the way, just delete it all. 120, there we go. 120, here, just delete the whole thing. Ah, damn it, now I don't have a minus. Shit. I'll put in 0. Right. Because the keyboard doesn't have a minus symbol. So 120, actually minus 100. So 120 is the maximum current that you want to allow. And the other one is the max braking current. And you typically don't need quite as much for braking. So minus 100 for braking is plenty. And now the absolute maximum current. That depends on what you've set in max motor current. So the best practice is to do 50% more than your max current. So for 120, that means 180. That's the right value. Slow ABS should be off, and all the other values stay, and then here we have battery currents. So this depends on your battery. So this here is a 18650 pack, similar to basically the same pack as a Fungineers pack with the P28A cells, and that one is good for about 40 amps max current. Yeah, it's rated for 70, but I find that plenty. Plus this board is written by my son, so he's not heavy, and 40 is fine. You can set 50, but you don't really need to go all the way up to 70, and I wouldn't set it to 70. And the rest you leave as is. We're going to hit write. That writes these settings, especially if you have a bad Bluetooth connection, you might end up losing your changes and it reconnects. So I'm just going to hit write right now. So we have that saved. Now we go to voltage. These also are always wrong when they're set by the wizard, because they're set assuming that these cutoffs will be used to prevent you from damaging your battery, but we actually use tiltbacks. So these cutoffs are more of a last resort. If your drunk buddy borrows your board and ignores tiltback and they just keep riding anyway, this will prevent them from killing your battery. But what we want to do is 2.7 times the number of cells, so 54 for a 20S battery, and 2.5 for cutoff end times 20, so that's 50, and that is that. Waiting right. Now, RPM we don't need to touch. Don't put in an RPM. If you think you want to limit how fast your board can go, this is not the way to do it. So the ERPM limit is really at what speed would you like to nosedive? And that's not what we want. You can, some people do use these ERPM limits to limit the free spin. So for tricks, you could limit this to whatever, 10,000 ERPM if you know you're not going to go fast. But for now, I would ignore it at first. Wattage, temperature, that's an important one, because here the default, I thought it was going to load defaults. Oh, yeah, so I'm running custom firmware, and I have already changed the defaults for what I think is the appropriate values. So typically you would get in here and see 15, and you want to change that to 0. And then we have the temperature cutoffs. So I like to set the MOSFET cutoff to around 70, 75. Actually here we should set that to 75, and then 85 here. If you have a battery in the front, I would set it lower. I would not let my controller hit 75 if it's right next to a battery in the front. And then the motor cutoffs, yeah, 80 to 95. So basically, yeah, you don't want your motor to get hotter than 80, and that will help with it. And then we have BMS. If you do have a VESC BMS, you set that to true, otherwise you say none. If you have any other BMS, a ZBMS, Pickles, whatnot, Max Kago, you will say none. And that's that. In advanced, I don't believe we change anything. You see this maximum input voltage? Do not touch it. Set it to the maximum it allows. Especially U-Box users, you have to increase it, put in whatever it lets you get away with. The Spintent guys are idiots for setting these lower than necessary. So many people have had nosedives because of those voltages being set too low. So you have to take care of that. The rest is fine. So I'm hitting right again. Now, FOC. FOC General, so you should see Hall Sensors as sensor mode up there. And If you have motor crunch issues, this is where you'll be doing most of your tuning, but I won't go into motor crunch troubleshooting. And this motor inductance difference. Typically, healthy values will be between 30 and 60. If you have something that is much higher than that or much lower, it typically indicates some kind of problem. You want to rerun your detection again, really check your wiring, but it shouldn't be outside of that range. And the other values, yeah, the observer gain, that's always kind of a good idea to roughly cut that in half. So I'm going to set mine to 0.8. I typically don't like to go below 0.75, so I'll set it to that. Now, sensorless, we don't touch anything in here. Some people like to use saturation compensation. Yeah, in that last video I made, I did mention this as an option, but it turns out that if you do use saturation compensation, you're actually just reducing the maximum power it can output during the low speed transition into sensorless. So it is more masking the problem than actually eliminating it. So you don't really want to resort to this, but it definitely helps eliminate the crunch at the expense of performance. Hall sensors. This one is a common one that we need to go into. Hall sensor interpolation ERPM. I think the default is 500, so you want to set that to 250. The Hall table you don't touch. Hall sensor extra samples. This is something that if you have crunch issues, you may want to increase that. And I've heard that people have had good results all the way up to like 5, 6, or 7. So that's something to consider later once you do crunch troubleshooting. At first, I wouldn't touch it. Encoder we don't use, HFI we don't use, VSS we don't use, filters, offsets. Offsets is an important one. You want to have run calibration at boot enabled at first, and then after the first few times you can turn that off, hit right so it saves the settings, but that will accelerate boot, the boot time, and that's all good. Also, this is not available on the phone app. In 6.5 it will be available, but in here it's missing the option to manually detect the offsets. Some controllers like the X12, the calibration at boot actually tends to happen too early, so it doesn't get the optimum results. So you want to do the calibration manually. Right now this is only possible using the PC desktop app or a 6.5 version of the tool, of the phone app. And field weakening. This is also very important. You want to start with 30 amps for something like the Fungineers battery. My son actually has been using 40 right here. So that's fairly safe on that battery. If you have the beefier torque pack or something like that, you can also get away with 50. The float wheel, they use 50, and that's been proven to be pretty reliable. So that's a safe value to use. But don't go too much higher because people have reported weird behavior, like board didn't stop accelerating, things like that. So it's not worth it. If you want to go faster, there is other options to try out first. So then the duties start. You want that somewhere around 65 or 60. I wouldn't set it any lower than that. And then the ramp time, I like to keep it fairly low, but let's say 300. And then some people report they feel a nose dip when field weakening is kicking in. And to be clear, it's not really kicking in. It's not like all of a sudden at 65% it turns on like a turbocharger. Instead, at 65%, you still have zero field weakening, and then it gradually increases it all the way up to 95. Or most likely, this nose hunting issue that you feel at around field weakening speeds is caused by some interference and resonance effects with the zero vector frequency, which we will now see in the next tab in advanced. So we have this zero vector frequency. This is the one that you want to tune. And we used to only go up and down by 1 kilohertz here, but actually if you like, so the way you want to go about it, changing this frequency changes the sound of the controller. So it will make a noise at about half that frequency. So the lower this is, the more likely you are to hear it, and it'll be anywhere between noticeable to unpleasant and annoying. And so you want to pick a frequency that you find least annoying, and then you want to go up and down in increments of 0.1 in order to eliminate any kind of resonance effects causing potential nose dipping. So let's say you like 27, so stick to that and then try riding it. If you feel any kind of weird nose hunting at those speeds, or some people feel it when going uphill under load, even at lower speeds at 10, 15 miles an hour, there's like weird nose hunting behavior. That in most cases fixes it if you just try incrementing the zero vector frequency by 0.1 or multiples of 0.1. So that is that. And then here, the observer type. That is another popular thing people change. I think the consensus is that Ortega Lambda is the most likely to give you good results and eliminate crunch. But for now, I'll leave mine at the default, which is MX Lemming Lambda. For those of you who are adventurous, if you want to go faster, set MTPA to IQ target. Keep your field weakening a bit lower than you normally would, just do 30. This will allow you to go even faster, but please understand that this is still experimental. We don't have a lot of testing done with this, and but some people have reported great results with it, so give it a try if you're really keen on going as fast as possible. All right, and the only other thing to note is additional info. If your speed isn't reading correctly, this is the area where you want to make changes. Up here we got the motor poles, that needs to be 30, gear ratio, this was that direct drive in the Wizard, it needs to be 1.0, and then here is the wheel diameter. And I never bother measuring the diameter with a tape measure or anything like that. I just set it to a value, I ride it, I compare my measured distance to the GPS distance, and use that to compute what percentage I'm off by, and then I adjust the wheel diameter that way until my GPS speed and the VESC speed line up. All right, now we got app config. In app config, we don't really need to do anything. VESC ID, if you have a Thor or a X12 with they use this VESC Express. And if you have that and you also have a Enoid X-Lite BMS, then it does help with third-party apps like Float Control and Floaty, especially Float Control, to have this VESC ID of your controller be lower than the VESC ID of the BMS. And that way, I think it makes it at least more likely that it'll pick up the controller first before the BMS. So that's just a trick to keep in mind. For boards with auto shutdown, this off after 30 minutes can be changed to turn off more quickly. So this only works, of course, for devices like the Thor, the U-Box with the momentary switch, and that's about it. The other controllers, they only have latching switches, so they don't turn off automatically. Also, this does not affect the float wheel, even though the float wheel has momentary switch support, same for GTV, because there the handling, the whole logic for controlling the auto shutdown is on the LCM module and not controlled by VESC code. And now the only thing that's left is the IMU. The IMU, that's the thing that detects your orientation, and that's your accelerometer, gyroscope, and everything. Here's where you would fine tune, but for that we do have a wizard. So we'll go back to start. So set up IMU. We start with the IMU configurator, and when you hit search for IMU, personally, I have never seen this work. I've seen some videos where some people got it to work. Supposedly, sometimes it works, but I've never seen it work. So don't stress about it. This is perfectly normal. But what is important is that you select balance skateboard here. So even if search for IMU doesn't work, you are not allowed to skip this step. And a lot of people, for some reason, seem to do that. The detection doesn't work, and then they just hit cancel here instead of selecting balance skateboard and save. And then they end up with an ultra stiff board. So you don't want to do that. Balance skateboard, hit save, and move on. But because the IMU didn't get detected, we don't know what the optimum frequency is, and we will have to set that manually. So next step, gyroscope calibration. This is really easy. The board has been steady the whole time, so I just hit save, done. And now the orientation calibration. I skip accelerometer because in most cases you don't need the accelerometer calibration to get your board working, but we'll do that later to fine tune it. So skip it, hit orientation calibration. Yeah, we got the board level, and don't get out your level now and try to get it perfectly level. That doesn't do anything. Just put it down, eyeball it, and it's level enough. And then you can later ride the board and actually fully calibrate it until it really feels equal in both directions. At least that's how I do it. The automatic calibration never works perfectly in my experience. So just have it roughly calibrated. All right, now this one here. So we have to raise the board by 45 degrees. So it is important to lift the nose of the board, not the tail. So there was an old version of the firmware that required you to raise the tail. So it's already at -90, so I hit save, and we're good. Yeah, so I wouldn't touch the accelerometer. Now you hit close or cancel, and that's the whole setup. By the way, people that go now into controls and control their motor with these forward and reverse buttons, doesn't even work for me right now. I'm not sure why, but it really doesn't matter. It's a pretty useless feature for the success of your setup. We've already seen it rotate when we did the motor detection, so it works just fine. Oh yeah, so now because it did not detect the IMU correctly, we need to go into app config, IMU, and we need to set the sample rate. I think the default is 1000, but for most of us, it's either 800 or 832. I'll put in the description which controllers use 800, which ones use 832. So, and I do have a video on how to adjust the orientation. That's here, this rotation section. I have a video on how to level your board if you change rails or anything like that, but also after first setup, how to really get it to be perfectly level. So I have a video on that, and I'm not going to repeat it here. And now it's time for the package. You want to hit Update Archive, and that will then load the latest version of all the packages. I highly recommend you install Refloat, and then I already have it, so I'll skip it now, and I'll go into Refloat config. I'll just do read defaults. So it starts off with the defaults. And the first thing you want to do is you want to go into specs. And initially, that's actually the only thing you need to do. In specs, you want to change the loop hertz. This is great. Change it to 800, or actually change it so that it matches your IMU frequency. If you needed 800 in the IMU, you want 800 in the package frequency. If you had 832, you want 832. Then you have your voltage thresholds. This one here seems to be set for 77. That would be the equivalent for a 18S pack, but we want high voltage tilt back at about 2 volts above max voltage, so 86 would be what I use for 20S, and then we want 60 for low voltage tilt back. That's 3 volts per cell, and that is everything. Oh yeah, enable beeper. I always like to have my buzzer enabled. And then if you do have LEDs, I don't have any here, you have to set that up here. I'm not much of an LED guy, so I don't want to talk about that. It's not important, doesn't affect your writing. So yeah, once you have that, you hit write. Now you should be good to go. So now, some people now want to just hop on the board, and others are scared and they want to try things out on the bench. But on the bench, the board doesn't quite behave the way you may think it will behave, so it will just get you worried for no reason. And jumping on the board is also not quite safe. If you're young and brave and can't get hurt, fine, just jump on and see. If you're lucky, there is a 50% chance it'll just work. But the best way to do this is to first turn on the app UI. And this is the Refloat app UI, but even the other, the Float app UI, it's not nearly as nice, but it still gives you all the information that you need, just only in numeric form. But the first thing you want to do is to verify that your foot sensors work. So you can press one here, you can press the other. Oops, where is it? See. So let's first try the foot sensors. If you press one side, you should see one number go up and the other. Here we have the nice symbols, so that works. Also, your board should look like it's level, and it's leveling out when you're leveling it here. And if it shows up upside down, or the pitch number is around 180, I think this is what it looks like if it were the wrong way. Oh, I would say that's kind of a bug in Refloat. Never mind, doesn't help. Huh, interesting. Well, so I royally screwed this up. I totally didn't expect my board to be upside down, and I was looking for pitch, but actually what I should have looked for is roll, because I believe that pitch only goes from -180 to +180, And in the end, it always ends up being a roll that will be close to 180. But either way, so you got to look for both. And I wasn't looking at the roll number. And that is basically what should have told me that my board is detected as being upside down, which means that my IMU was not detected correctly. Obviously, my IMU is not set up well. So here is the right way how to run the wizard again. The first thing you want to do is you go into app config and you say read default settings. Okay, so we've read the defaults, we gotta hit right. Now we go back to running the IMU setup. If you don't do this, then you get worse and worse values each time because they seem to be cumulative rather than starting from scratch. So let's bring the board roughly level and we'll say roll calibration here, save. And now pitch offset, we'll again level the board, save. And now the yaw offset. Okay, so 0 looks better than what we had before. All right, very good. And I think I got the wrong values last time because my board was already set up and I only reset the motor config. I didn't reset the app config. So that obviously was the reason why my board was considered upside down. So now that I did the read defaults and applied the defaults back to the app config, I obviously should be doing all of the IMU configuration again, not just the orientation calibration. If this was done correctly now, we should see, all right, now I can see that my roll is actually close to 0. And I'm still in hand test mode, which is perfect. So now, when I press down on the foot sensors, left one, right one, okay, and now here is my board. And the reason why this is important is the currents right now are limited to just 10 amps, which means you can easily overpower it. You see I can press it all the way down, and that means you don't get a burnout in your carpet. It doesn't run away and punch a hole in your wall. So this is much safer than running with full power. So this is why hand test is the way to do it. If you press on the sensors and instead of the board just sort of staying level, it wants to run away from you and you have to hold on to it, then that means that the direction is reversed. And the first thing you would want to do is you would then go into motor config, and on the first page you would just do invert motor direction. But mine was balancing correctly, so I won't do that. So now we can disable the hand test, turn hand test off, and now we should be able to balance with full power. So now it's safe to get on the board and it should work just fine. There we go. Now it's working. So this is the initial setup, and that's what you need to do. I hope that covers pretty much every situation, and if not, then there's always the Discord and the Facebook groups, but hopefully that covered it all. And then there's tuning and so on, but that's separate. You should be able to ride on the default tune and it should be just fine. Maybe it's not your preferred behavior of the board, but it shouldn't be horrible. It shouldn't be super weird. It shouldn't be janky. It should just maybe not match your preferences. So if that's not the case, something's wrong with your IMU. Accelerometer calibration, I skipped it. I think there's plenty of videos that cover it. The number one reason that you want to do accelerometer calibration is if you do drops and your board ends up being really weird, nose up, nose down after a drop, or if you do a quick U-turn, same thing. The right way, the only way to do backup is there is this button here. It says backup configs. So when you press that, it will save your motor config, your app config, and your float config. A common reason why it wouldn't save all three is you've just powered on your board, you connect to it, and the app UI is not yet loaded when you hit backup configs. And in that case, it will only save motor and app config. So when you restore, you don't get your float or refloat config restored with it. That's why you want to wait. Same for restoring. You need to wait until you see app UI, then you hit restore, and then it'll restore all three, provided all three were saved. So that's backup. Once you have a working board, go and back it up. And additionally, you can save files, but that's a pain in the neck on the phone. So I only do that on the computer. But it is possible, at least on Android. I'm not sure on iPhone. Good luck working with files. So that's all I got. Enjoy.